Hello all. So in this video we will discuss Twiddle factors and its properties, majorly its properties only. And the target is the same, that we have to derive the mathematical formulation, it is a matrix formulation to calculate DFT of sequence. And for that we need to know some properties because it is applied in that matrix that we have derived in last lecture. So after that after deriving these properties and using one of the properties from this, we will again shift towards that for matrix formulation and derive an important result which is very much useful in each and every problems in examination. So let's move towards Twiddle factor. So first of all, what is Twiddle factor? Twiddle factor is defined as e raised to minus j 2 pi by n. Okay, so this is Twiddle factor. So using identity, we can simply write like this, and anything which is written like this, okay, that is its magnitude, let's say it is 1. Okay, so this is magnitude is 1, and not let's say, it is already 1. So magnitude is 1, and what is this? This is phase. So we can say that Wn is a complex quantity whose magnitude is 1 and whose angle, that is phase angle, is nothing but minus 2 pi by n, because whatever in power of e, whatever is in with j in power of e is nothing but phase. So it is minus 2 pi by n is the phase. So also, since Wn raised to n is nothing but 1, why 1? Because this n will cancel and we are left with e raised to minus j2 pi, which is nothing but 1. So it is 1. So we can also call it as nth root of unity. I hope you know what is nth root of unity, cube root of unity, and so on. So this is just for information. So our target is to shift towards properties. So we are shifting towards properties, and this is the property number 1, that is Wn raised to n by 4 is nothing but minus j. It is very much obvious that if you substitute n by 4, let me give the proof. I am just proving only one property, rest are for your homework. So this Wn is nothing but e raised to minus j 2 pi by n. This is Wn. So Wn raised to n by 4 is nothing but e raised to minus j 2 pi by n power n by 4, that is in multiplication we will get n by 4. So this n will cancel and this will give e raised to minus j pi by 2, and according to this identity it is nothing but minus j. So it is written minus j. Now next, Wn raised to n by 2 is nothing but minus 1. Similarly, Wn raised to 3n by 4 is nothing but j, and similarly Wn raised to n is 1, which we have already seen. Now fifth property, it is also called periodicity property. So I hope you will derive the proof for all of this. So periodicity property says that Wn raised to k plus n is nothing but Wn raised to k. Okay, so this is the periodicity property, and let's move towards its proof. So this is the proof. Now what's the proof? Wn raised to k plus n. How to proceed? Simple, just substitute. Clear? So just splitting power, and it is e raised to minus j 2 pi, because this n and n will get cancelled. So this is in multiplication both. So this is nothing but 1. So we are left with e raised to minus j 2 pi by n into k, and it is nothing but Wn raised to k. So hence proved. One more property, let me write over here only, seventh property, that Wn raised to 2k equals to W raised to wn by 2 raised to k. This is important. Let me repeat, wn raised to 2k. This 2 will come in division with this n. Clear? So proof. Simply starting with left hand side, e raised to minus j2 pi by n into 2k. Just shift this 2 in denominator. So we can write like this by n by 2 times k, and it is nothing but wn raised to n by 2 power k. Clear? So this is something tricky type, not that much tricky, but yeah, I recommend that you derive it once. So let's move towards next property, and I am writing this property over here, this side. So this property is nothing but symmetric property. 6th number, that is symmetric property. I hope the sequence is right. Sorry, 5, then 6, then this is 7. Here, so this is 7th property. It's symmetric property. It states that wn raised to k plus n by 2 is nothing but minus times wn raised to k. Clear? So what was the periodic property? Was that wn raised to k plus n is same as wn raised to k. Here, if we are having n by 2, then we are having minus sign in front. Now let's prove it. So proof. So simply starting e raised to minus j2 pi by n into k plus n by 2, same. So e raised to minus j2 pi by n into k, and this n will get cancelled, 2 will also cancel, and we are left with j pi only. And this j pi is nothing but minus 1. So what we will get? We will get minus times of e raised to minus j2 pi by n times k, and it is nothing but minus wn raised to k. Clear? I hope it is visible. Yeah. So 8th property. This is important. wn raised to conjugate, that is wn's conjugate, is nothing but wn raised to minus 1. Now let's prove it. wn star, starting with left hand side. So we have this conjugate. So conjugate will just replace the sign by positive, and it is nothing but wn raised to minus 1. Clear? So it is nothing but we have proved. Now I have to warn you, I hope it is visible now. So I have to warn you that again, just see this, wn raised to wn into wn star equals n into in. Recall that all this are matrices. That's why I have been writing this matrices in bold form, okay, throughout the explanations. So because this is identity matrix, all this is matrix, okay, but over here this is not matrix. So don't mash up this two, this one and this one. So don't mash up. This is a Twiddle factor, simple Twiddle factor. This is matrix form of the Twiddle factor, though both are looking the same, but don't mash it up, okay, because if you will multiply by wn inverse both the sides, you will get same thing. No, don't do all this stuffs out here. This is only possible if we are having the matrices, then and only then we can multiply by wn matrix both the side, then this will become identity matrix, and so on and so forth. But this is not the case over here. So don't mess up with these two properties. It is this one, 8th property, and this equation. Clear? Now let's move towards our matrix formulation. That is what we got over here. We got Wn like this, and we have considered for simplicity n equals to 4. And in most of the examinations, we will be dealing with n equals to 4 only. Okay, so substituting n equals to 4 in this equation, okay, we will get W4. So I am writing just here only W4. So just see what W4 is. So it is 1 1 1 1. We will get W4 is to 1, W4 is to 2, W4 is to 3. I am writing fast. 4 6. This we have already written. Clear? I also told that just remember, like table of 1, table of 2, and table of 3. This is in matrix form. Now just using the properties of Twiddle factor, what we are doing some modifications. So ones are as it is. This W4 raised to 1, W4 raised to 2, and W4 raised to 3 is also as it is. 2 4 6. Let us write. Now we will modify this. Okay, so by using property, just we have derived W4 raised to 4 can be written as W4 raised to 0. Okay, by which property? Yes, periodicity property. Clear? So what we can write, W4 raised to 4 can be written as W4 raised to 0. Similarly, W4 raised to 6 can be written as W4 raised to 2. Again, this is 6, so W4 raised to 2, and this is 9. This is important. What to write W4 raised to 9? Obviously, it is W4 raised to 1. Why so? Because we have n equals to 4. So after every 4, we will have repetition. So once 0 to 4, that is 0 to 0, 1, 2, 3, that is 4 we have covered. So after every 4, we have repetition. That is, you can forget about this. Consider like this, that 1 2 3 4, then 5 6 7 8. So 2 cycles are complete. Then again we are having 9. 1 2 3 4 5 6 7 8, then 9. So we are start 9 means again 1. So it is nothing but W4 raised to 1. Now let's substitute over here. We can write the reason that by periodicity property. So now what we will do, just substituting the values, we know each and every one. Okay, so 1 1 1 1, W4 raised to 1, we know it's minus j, it is minus 1, it is j, it is minus 1, then this is 1, anything raised to 0, then j, then again j, minus 1, and minus j. All these are 1. Don't mesh. Okay, so these are minus j, these are plus j, all these are minus 1, and in the center we are having 1. Clear? So this is the general formula to calculate the DFT. How? So what we have done, going through the formula, we have derived this general equation, and from in this the summation is being included. Then only then we are getting this 4 terms, because we have assumed here n equals to 4. This is generalized one. We have n equals to 4 1 over here, the very first lecture. Okay, so the summation is being covered. So what is not covered is that this x of n. So what we do to find DFT, just simply multiply this by x of n, that is the sequence. Okay, in discrete domain, what we are having, just multiply and we will get our answer. Okay, so if you are not getting, then let us move towards one example. So One example, very simple example we will consider. Suppose, let's say we are given any sequence x of n equals 0, 1, 2, 3. Okay, and we have to find its 4-point DFT. Over here also we are having 4 points, 0, 1, 2, 3. It is 4 in total. So we have to find x of k. So what we will do, just simply replace that matrix and multiply 0, 1, 2, 3. Okay, by this matrix and 0, 1, 2, 3, just matrix multiplication, and you will get one column matrix, and it is, suppose, x of 0, x of 1, x of 2 and x of 3. Whatever value we get is nothing our x of k. Clear? So I hope you will do it as your homework. So that's all for this. Thank you.